Let's have a look at some numericals associated with thermochemistry. So what is the expression of lattice energy? The formation of calcium bromide. So first of all, calcium is a solid. So this solid should be converted into gas. That is called sublimation energy, yes. So this calcium should be converted into Ca+2. Actually, our basic goal is to prepare CaBr2. That means CaBr2, how it will be formed? Ca+2 should form, Br minus should form. These should be in the gaseous format. Then only CaBr2 will be formed. So to do this, IE1 plus IU. IA1 means only one Ca plus will become Ca+2. So Ca+2 does become. So it is also in the gaseous state. Now, bromine. So bromine is a liquid or a gas? Bromine is liquid, na?
Yes, sir.
So it can be in the gaseous form
Yes,
also.
sir.
Now you can dissociate. It will become 2Br. Dissociation energy.
Yes, sir.
Now 2Br means two electrons you add. Electron affinity. It becomes 2Br minus. This is electron affinity. Clear? Yeah. Now
Yes, sir.
sublimation energy plus ionization energy 1, ionization energy 2, dissociation energy and electron affinity. Finally, lattice energy. This is lattice energy minus U. This is lattice energy. So this is one step, heat of formation. So heat of formation is equal to delta HF. Heat of formation. When the reaction is taking one step or a series of steps, it is same. So what are the series of steps? Sublimation energy plus IE1 plus IE2 plus dissociation energy plus electron affinity and lattice energy. The summation of all these things is equal to in one step heat of formation of CaBr2 from its constituent elements. I hope you understood this. So this is Hess law Born-Haber cycle. So let us solve another question. Heat of transition of carbon is given. So diamond, when you oxidize, you get CO2 and the heat liberated is minus 94.3. Minus is exothermic process. Similarly, amorphous plus O2 gives rise to CO2 minus 97.6 kilocalories. Now, what is required? The heat of transition. Heat of transition means diamond to, so C diamond to C amorphous, you have to convert. So first of all, C diamond, which side is it? Which side is it in the first equation? Left side.
So in the left
Left
side.
side. In the requirement also left side only is there. Are you following? So directly minus 94.3 you take. No need to do minus. Now, C amorphous is which side here?
Right side, sir. So we
Here which
should
side it
subtract.
is there? Left side. So
Left
what you
side,
have to
sir.
do? Plus.
Subtract.
Plus.
And
So
Yes, sir.
97.6.
It will come right side. And
So you add these two. Are you following? Subtract, sorry. Subtract this. Clear or not? This minus
yes,
this.
sir.
So you get 3.3. These 3.3 only, no? 3.3 kilocalories you'll get. Hope you are clear.
yes, sir.
So this is a
Yes,
previous. This is a previous mains question. Easy question, actually. Now, let us see. Same question. Another question. White phosphorus. Actually, white phosphorus is like this. Tetrahedral structure. White phosphorus. White phosphorus is very reactive. Why? The internal bond angle is 60. What should the bond angle actually? 109 degrees. sp3, na? sp3, what should be the bond angle? 109 degrees.
109 degrees, 20.
Yes, sir.
But here 60 degrees is
Yes,
there.
sir.
There is a strain. That's why it is very reactive. So
Yes,
this
sir.
will be converted into red phosphorus. So this is red phosphorus. You know what is red phosphorus? Matchboxes, na? Matchboxes you light up or not?
Yes, sir.
Yes, sir.
Yeah, that is red phosphorus. Okay, this is red phosphorus. Okay, so white phosphorus can be converted into red phosphorus because red phosphorus is more stable. Is more stable because it is polymeric form. What is this form?
Polymeric.
Polymeric form.
Polymeric. So that's the answer. Now, the standard heat of formation at 298 Kelvin for CCl4 gas, H2O gas, CO2 gas, HCl is given. So they're all heat of formation. Okay. Calculate heat of reaction. So what is the formula for heat of reaction? Anyone? Heat of reaction formula.
Delta H reactants minus delta H products, sir.
Products minus reactants. Heat of formation of products minus heat of formation of reactants. Clear? Yeah.
Yes, sir.
Yes, sir.
Combustion is reactant minus products. Combustion. Now have a look here. So first of all, products is CO2. So CO2 is how much? Minus 94.1. So write this in a second. Yeah. Now minus 94.1 is heat of formation of CO2. 4 into HCl. So 4 into HCl. HCl is given 22.1. So this is reactants is over. Next minus products. CCl4. Heat of formation of CCl4 is minus 25.5. It's exothermic reaction. Heat of formation of water minus 57.8. 2 into because 2 moles is given here. So you'll be getting plus 135.8. So net reaction is what? Endothermic in nature. Net reaction is endothermic in nature. Are you clear or not?
Yes, sir.
Yeah. Now, nice question. The molar heats of combustion of C2H2 is given. So graphite is given. H2 is given. So write the combustion reactions. Always you should write like this. C2H2 plus O2 gives rise to CO2 water. Then 2 are there here. Write 2. Next. Oxygens. Here how many are there? Total
1, sir.
5 are there.
Total 3, sir.
5.
Okay, total 5.
So 5, 2, 2, 4 and 1, 5. So 5 by 2. So balance it. Similarly, graphite. Write the combustion reaction. H2 also write the combustion reaction. So question, what is the question? Heat of formation of C2H2. Clear or not?
Yes, sir.
So
Yes,
heat of
sir.
formation of C2H2 means what? 2 carbon plus
Plus H2.
H2 gives rise to C2H2. This you
Yes, sir.
require. Now listen carefully. Carbon is which side?
Left side,
Sir,
sir.
left side, sir.
Which side is it?
Left
side.
side, sir.
This is plus. Okay, next. Hydrogen is which side?
Left side, sir.
Left
This
side
is which
only,
side?
sir.
Left side. This is also plus. Next. Acetylene is which side?
Left side, sir.
Left
So
side.
right
Right
side it is
side,
there.
sir.
Right side
Here,
it is there.
right side, sir.
Right side.
Right
So
side.
here which side it is there? Left.
Left,
sir.
sir.
So you have to do
left side,
minus.
sir.
You have to do minus.
Okay, sir.
Are you following? Now see 3 plus 2 into 2 minus. I hope you are clear.
Yes, sir.
Yes, sir.
But listen
sir.
carefully. Here H2 how many moles are there?
2
1 mole.
moles.
2
1 mole.
moles.
1 mole. Na? Here 1 mole is there. So whatever the needed stoichiometry you have to do. Clear or not?
Yes, sir. Carbon is 2 moles,
Yes,
sir.
sir.
Here carbon is how many moles?
1, sir.
2, sir.
Here how many is required?
2,
2
2
is
moles.
required. So 2 into that.
Into-
That's why 2 into 2 you do.
Yes, sir.
See, very simple technique. Simple technique is, see, first and foremost thing is the given equation. These two are left side is there. So these two are left side is there. These two are left side. So these
Yes,
two you
sir.
should do plus. Next, see the stoichiometry. Stoichiometry is considered 2C is there. That's why this should multiply this equation with 2. I hope you are clear. Okay. And now,
Yes, sir.
Yes, sir.
now
Yes,
this
sir.
one you see, this is in the right side. So naturally, this should you should do minus to get the acetylene. I hope you are clear. Am I clear? This is right side.
Yes, sir.
Yeah.
Yes, sir.
So this is how should work out. Next question. The molar heat of formation of ammonium nitrate is minus 367.54 kilojoules. And that of N2O and water is given at 1 atmosphere. Calculate delta H and delta E for the reaction. So very simple. Always heat of reaction is nothing but products minus reactants. Okay, products minus reactants. So here all the values are given. You write the products minus reactants, it comes out to be minus 122. Are you clear or not?
Yes, sir.
Yes,
Minus
sir.
122. Now delta H you got it. Because this is kilo. Kilo means 10 power 3. That's why minus 122 minus 1,22,600 will be calories. Delta E you have to find out. Number of moles. Number of moles is how much here? Gaseous moles. 1. Agreed, na?
1, sir.
0. 1
Yes,
minus
sir,
0. 1 minus 0, na? Here nothing
Yes,
is
sir.
there. This is a solid.
Yes.
This is a liquid.
That's a liquid, sir. Yes.
So this is 1 into joules, na? 8.314. Temperature is given 25 degrees. So take 298. Get the answer delta. Easy. So first what you have to do? You have to basically find heat of
Delta H.
reaction from
Delta
products
H.
minus reactants. I hope you are clear.
Yes, sir.
Because
Yes,
heat of formations are given. When heat of formations are given, already you know the heat of reaction, you know how to find out. Heat of reaction, how to find out heat of reaction, heat of products minus heat of
heat of
reactants. That's what you have to do. Now another question. Determine the value of delta H and delta E for the reversible isothermal evaporation of 9 grams of water at 100 degrees centigrade. Assume that water vapor behaves like an ideal gas and heat of vaporization is 540 calories per gram. Yeah. Now, I think you know the formula delta H is equal to ml, latent heat of vaporization. You know this formula?
Yes, sir.
So this is m mass 90. 90 grams is the mass. Can you see here in the question? 90 grams is given here.
Yes,
Yes,
sir.
sir.
And heat of vaporization is given 540 calories per gram.
Yes,
so here,
sir.
here gram and gram gets cancelled. You get calories. Clear or not?
Yes, sir.
Yes,
yes,
sir.
sir.
Yeah. So delta H is equal to delta E. So delta H value, you know, number of moles. Number of moles, how do you find? How many grams is given, right? 90 grams. Water is the
Yes,
90
sir.
grams.
90 by
90 by 18, sir.
18. So that is the number
Yes.
of mole, weight by molecular weight. R, because here R is in calories. You have to take in
Yes,
calories.
Two,
sir.
sir.
2
R is
calories.
equal to 1.987. That is equal to
Yes,
2 calories you can
approximately
take.
2
2.
calories.
So temperature is given 100 degrees centigrade.
Yes,
So
sir.
find out as follows. Any problem?
No, sir.
No, sir.
No, sir.
Yeah, it's a nice question. See, an athlete is given 100 grams of glucose of energy equivalent to 15,600 kilojoules. So 100 grams of glucose is giving the energy 15,600 kilojoules. But he utilizes only 50% of the gained energy in this event. In order to avoid storage of energy in the body, calculate the weight of water he would need to perspire. Enthalpy of water for evaporization is 44 kilojoules. It's a nice question. Let us see. So energy gained by the athlete is how much? Energy gained by the
15,600 kilojoules.
15,600.
600. His mistake is there. It is 600.
So one more zero, sir.
One more zero is there. Yeah. Now, in this energy, see, after consuming 100 grams of glucose, this much energy he got, but he used only 50% energy, right? Na?
Yes, sir.
Yes,
50%
sir.
energy only gained. So 50 by 100. That is 780 kilojoules. He got it. Okay.
No, sir.
So-
7,800.
7,800, sir.
7,800. Huh?
Yes,
Yes,
sir.
sir.
Extra zero added, sir.
I think
Yes, sir.
I think it is only 1560. I think. But throughout the calculation, he has maintained that
Then
way.
it's 780, sir.
Yes, sir.
Is it
Then
okay?
it's correct.
Okay. So 780. Now energy left will be how much? Half of it. 50% means half only, na?
Yes, sir.
Half will be
Yes,
left
sir.
over. Okay. Now listen. 44 kilojoules energy is required to evaporate 18 grams of water. It is given na per mole na. 44
Yes, sir.
kilojoules
Yes.
per mole means 18 grams. One mole
Yes,
is
sir.
18 grams
Yes,
of water.
sir.
Na? One
Yes,
mole
sir.
is 18 grams of water. 780 kilojoules means how much? That's it. That's the answer. Slightly logical. Easy only. Am I clear?
Yes,
Yes,
sir.
Yeah. Yeah. You know CP, CV and all? These formulas you know or not?
Yes, sir.
Yes, sir.
Yes,
R
sir.
by CP minus
yes,
CV.
sir.
Nearest
Yes, sir.
relationship, sir.
Yes, sir.
The specific heat at constant volume for a gas 0.075 calories per gram and at constant pressure 0.125 calories per mole. Calculate the molecular weight of the gas, atomicity and number of atoms in its 1 mole. So this is specific heat at constant pressure. CP is given and CV is given. So naturally you'll find the molecular weight. CP minus CV is equal to R by M. So you'll get the molecular weight directly. Atomicity gamma is equal to CP by CV. You get atomicity also. So it is monatomic gas because 1.66 corresponds to monatomic. So this is elementary question, but however, this type of questions are also coming in the exam. Now, next question. When 1 mole of ice at 0 degrees centigrade and 4.6 mm of Hg is converted to water vapors at a constant temperature and pressure. So try to understand. 0 degrees ice is there. This should be converted into water vapor. So that means delta H is equal to heat of fusion plus heat of vapor. Do you agree or not?
Yes, sir.
Yes,
See,
sir.
this is ice. This should be converted into vapor. This is heat of fusion. And this should be converted into vapor.
Vapor.
This is a liquid. So this is vaporization. Clear? So total heat will be how much? Delta H fusion plus
Yes,
Plus
delta
sir.
H
delta H vaporization.
vaporization. So that's what it is. You get 12168 calories per mole. Any doubt?
No, sir.
No,
Agree or
sir.
not? So now rest of his this PV is equal to nRT, you write.
Yes, sir.
Now you get delta E. That's it. Finish. Clear or not?
Yes,
Yes.
sir.
Yes, sir.
Separately it is done. Separately it is done because delta H. You got delta H, na? Delta H is equal to delta E plus delta N RT. Are you clear or
Correct.
not?
Yes,
Yeah,
sir.
use this formula. Easy only. Yeah. Next question. Simple question. So here calculate the standard enthalpy in this reaction. So formations are given. Formations of production reactants are given. So naturally delta H reaction is equal to sigma heat of products minus sigma heat of formation of reactants. Right now? So heat of formation of zinc. Zinc is elemental state. So it is 0. Agree or not? This is 0, na? This
Yes,
is 0.
Yes,
sir.
sir.
CO2 is given. CO2 is given. Next, reactants. ZNO, CO2 is given. CO, sorry. ZNO and CO are given. So simply just do minus. Clear or not?
Yes, sir.
Yes, sir.
Yeah. Yeah. Calculate the enthalpy of vaporization of water from the following. So, listen carefully. So, how to do this question? Very simple. I want this step. Water, liquid should be converted into water vapor. Agreed, na? So, this is required.
Yes.
Now, this manipulation, how do you do the manipulation? First, H2O liquid is which side? Which side?
So towards
Right
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 side.
side.
sir.
But this should be
side,
converted
right
into
side.
left. So, this should be minus. Clear or not?
Yes, sir.
Yes.
Yes, sir. Yes, sir.
Gas is converted. Gas should be which side? Right. This is right
Yes,
only.
sir. So it's
So, this is
plus only,
plus.
sir.
Plus.
Plus, sir.
Finished now. Clear or not? Yeah. Now listen carefully. But there is a problem. Also calculate the heat required to change 1 gram of water liquid to gas. Okay. So here, you know very well, enthalpy of vaporization of water is 11.3 kilocalories per mole, na?
Yes, sir.
Yes, sir.
1 mole only, na? You did 1 mole only, na?
Yes,
So
sir.
1 mole means 18 grams. 1 mole means how
Yes,
many?
sir.
18 grams.
Yes, sir.
Yes, sir.
So 1 gram is asked actually. 1 gram how much? Clear?
Yes, sir.
This is per mole. So that is 18 grams, 11.3 kilocalories. 1 gram how much? Clear?
Yes, sir.
Okay. Oh, it's a wonderful question. Very, very important question. Many times asked in the competitive examination. Now, how to solve this question? Let us see. The standard enthalpy of combustion of H2, C6H10, cyclohexane are given. First, to write the reactions. Standard heat of combustion means what you have to do? Write the combustion reaction for all the three. These values are given. Clear? Clear or not?
Yes, sir.
First, write the combustion reaction for all the three. Next, calculate the heat of hydrogenation of cyclohexene. Heat of hydrogenation, this is cyclohexene. Okay. Heat of hydrogenation. What do you have to add? Hydrogen. What you will get? Cyclohexane you will get. This is the required reaction. Do you agree or not?
Yes, sir.
Yes, sir.
Yes, sir.
Now let us see. Left side. Here requirement is what? Left side cyclohexane should be there. Agreed? So in these three reactions, cyclohexane is which side?
Left side, sir.
Left side, sir.
Cyclohexane is C6H10. Left side only. Agreed or not? Left side only,
Yes,
na?
sir.
Here.
Yes,
So
sir.
this should be plus.
Yes,
Yes,
sir.
Next. H2. H2 is which side?
Left side only, sir.
Left,
Check out. Here. Left side.
Left side,
yes,
sir.
sir. Left side only, sir.
1 second. Just let me clear off everything. So this is plus first. This is plus. This also plus only.
Yes, sir.
These two are same side. Okay. Next. Requirement. This one. Cyclohexane is other side. Right side. This one. This is the required
Left.
reaction. Right side is there. But here which side is there?
Left side, sir. Left side, sir.
Left
So do
side,
minus.
Sir,
This one do
subtraction.
minus. Minus you do or not?
Yes, sir.
Yes, sir.
sir.
That's the answer. Is it all right?
Yes, sir.
Yes, sir.
Stoichiometry also is okay. 1 mole, 1 mole, 1 mole, all 1 mole only. You get the answer. So what you have to do, tell me. First and second reaction you have to add. Right now? First and second
Yes.
reaction you have to add. And then minus third
Third
reaction.
The third reaction.
So enthalpy do it. Hello, listen. Enthalpy is extensive property. Extensive properties are additive. That's why you are adding. Why you are adding the delta H1 and delta H2 and minus delta H3 you are doing? Because extensive properties you can add. Intensive properties you cannot add. Can you add 2 pH?
No, sir.
You cannot add. Nice subject is there, learn. Are you getting what I'm speaking?
Yes, sir.
Yes, sir.
This is how we should do questions in thermochemistry. Now, liquid. Now, what is the delta H for water from its constituent element? So water heat of formation is asked. Are you clear or not?
Yes,
What is the
sir.
question? Right? Heat of
Yes,
formation of
sir.
water is asked. From the constituent elements, what is asked? So reverse it. You soup, you reverse it, you get heat of formation of liquid water.
Yes, sir.
What is the
Yes, sir.
answer? What is the answer? Minus.
Minus 890.36.
Here plus is given. When you reverse it, you get heat of formation of water. That is the question.
Yes, sir.
Are you clear or
Okay,
not?
sir. Yes, sir.
Hope you're all clear. Okay.
Yes, sir.
Now, see the question. I want this one. These two are heat of formations are given. Heat of formation of CO2 is given. Okay. Let us see. Carbon, where is it? Which side?
Left side, sir.
Left
side,
side, sir.
Left side. 1 second. Yeah. So left side be this is plus or minus?
Plus,
Plus,
sir.
Carbon monoxide. Carbon monoxide which side?
Right side, sir.
Right
Which
side,
side
sir.
is it?
Minus.
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 It is minus.
Minus subtraction.
That's it. That is the answer. See here.
Yes, sir.
Clear or not? 3
Yes.
minus 2.
Yes, sir.
This is 3.
Yes, sir.
This is 2. Minus 2. You get the answer. So this is how you can solve thermochemistry questions. So please solve the questions, and in the next session, I will solve some more questions. I will be teaching some more concepts. Okay. In 3-4 sessions, I am going to complete chapter. And once the chapter is done, we are going to have revision for 2 months, first year revision. We are going to start. Am I clear?
Yes, sir.
Yes, sir.
Okay. Thanks for bearing. Have a good day.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.